Greetings, everyone. Today we are going to talk about Neuroanalyzer, also known as the talking brain. Now, it is a device which will analyze the neural activities. Then, from that analyzation, it is going to project data on a screen. Now, that screen, it could be either your smartphone, your desktop, or it can even be a pair of smart glasses in a couple of years. So, basically, the talking brain is an very advanced machine which can decode electrical signals of the brain and display it on a screen, as we just talked about. It can overcome the utmost challenging task. That is, it will be able to communicate with patients suffering from extreme paralysis. Let's talk about the machine. Now, in this proposed system, several techniques are used and combined to study and analyze brain activities. Superconducting quantum interface devices, that is, SQUIDs, are the utmost used sensor to sense the weak magnetic field of brain. And also, in order to measure brain activity in normal environment, a measurement system is required, which will be based on highly sensitive magnetoimpedance, that is the MI sensor, which will generate a report of study of measuring auditory evoked field, that is AEF brainwaves. Now, there is also going to be significant contribution of a BCI technology, that is a brain-computer interface, which will be used based on real-time brain processing. Now, the next thing is magnetoencephalography, is another well-known technique used to measure brain activity and areas of brain. Brain sensor is used, which senses the brain activities via electroencephalography, that is EEG sensors. Now, think it, think it. Now, this will play a crucial role in a machine. Now, what is it exactly? Well, it is a technology that is going to enable us to interface with the various brainwaves. It includes sensors that touch the forehead, the contact, and a reference point located in the ear clip, and on board chip that process all of the data. The raw brainwaves and e-sense meters both are calculated on ThinkAir. Now, the NeuroSky ThinkAir technology measures the analog electrical signals, commonly referred to as brainwaves, and process them into digital signals. Now, let's talk about brainwaves, in which our whole concept is based. The output signal from the brain is in form of different frequencies, and they range from zero point 0.1 hertz to 30 hertz, describing the particular brain type. And by selecting the particular brain type, we can detect the particular emotions. The brainwave speed are measured in hertz, and they are divided into bands, delineating slow, moderate, and fast waves. Now, one of the waves that we're going to talk about is the delta waves, which range between zero point 0.1 hertz to 3 hertz. Now, these waves, they are slow, loud brain waves. They are generated in deepest meditation and dreamless sleep. Healing and regenerating are stimulated in this state. That is why deep restorative sleep is also essential to the healing process. Then we have the theta waves, which range between 4 Hz to 7 Hz. Theta brainwaves occur most often in sleep, but are also dominant in deep meditation. Theta is a great way to learning, memory, and intuition. In theta, our senses are withdrawn from the external world and focused only on signals originating from within. It is that twilight state which we normally only experience fleetingly as we wake or drift off to sleep. In theta, we are in the dream, vivid imagery, intuition, and information beyond our normal conscious awareness. It's where we hold our stuff, our fears, troubled history, and nightmares.
Thank you, Aditya. The next are the alpha waves that range from 8 to 12 hertz. They are quietly flowing thoughts and are said to be relaxing for physical and mental state of mind. Alpha waves are stress relieving waves for our brain. They help in mental coordination, calmness, alertness, and mind and learning of the body. The next are the beta waves that range from 13 to 30 hertz. They are normal waking state of alertness and fast decision making of the body. They normally occur when we are awake, alert, or curious. They help in making focus and fast decisions. They are further divided into three bands. Low beta that range from 13 to 15 hertz, the beta that range from 16 to 20 hertz, and the high beta that range from 21 to 30 hertz. The continuous high frequency processing is not very efficient way to run the brain, as it can make tremendous amount of energy in our brain. Next are the microcontrollers. STM32 Nucleo 64 board develop board. The microcontrollers are used to program the interface of the brain sensors. So, whatever the reading of the brain sensor is given is controlled by the microcontroller and perform operation accordingly. Now, there are many challenges faced when uh, we work on this, but the major one are meditation, concentration, resolution of EEG is significant interface compared to MEG. Now, in the rarest state, when a person cannot even move its eye or eyelid, at least it can provide a link with the outside world. Now, some applications of this are: first, in medical sector, the paralyzed or the disabled. It helped the paralyzed or the disabled people to um, to meet the future with help to propose. The second application is lie detector, as it read the brain wave, so it can easily make out if the frequency of brain waves changes. The advantages of the same are: if a person is completely locked in a syndrome, he can also have a connect with the outside world. By reading the brain activity of a paralyzed person, we experts could tell whether the person responds in yes or no for a particular question. This can also help in monitoring the brain's blood flow. Now, coming on to the conclusion, one this thing can be possible in the future, as for long period that effectively collects, store, and smartly communicated neurological information about, along with the associated physiological data in an autonomous fashion, for why monitoring of patients with various neurological disorders. It can be gigantic step towards the new era of electronics. The references of this PPT are given below. Thank you.